Hello everybody, I'm Gleb and this is my 5G course on IoT Understanding channel. As for today, we're going to talk about 5G initial access procedure. And I want to show the fundamental difference between 5G NR cell initial access and LTE initial access. In this video, I will try to cover every possible step as far as it possible in such format. So when the user equipment is powered on, it starts with cell search and cell selection. Actually, it starts with PLMN search and PLMN selection to perform downlink synchronization with 5G base station and do it with proper mobile operator in the best condition. But before talking about signals, let's define 5G NR cell. And in 5G NR, cell is defined by the same SSB information. This is very important note. So let's look how SSB blocks organized in time domain space. In time domain, every synchronization signal block may have different numbers, and they organized in SSB burst set. Every SSB burst set is a periodical. This is inside 5 millisecond window, and the maximum number of SSB blocks, it depends on frequency carrier. For sub 3 GHz, this is 4. For sub 6 GHz, the maximum number of SSB blocks is 8, and 64 SSB blocks within one SSB burst set is 4 millimeter waves. This is organization in time domain. In space, the base station, 5G base station, use special antenna techniques that called beam sweeping. It form narrow beam, and the more SSB blocks, the more beams we have, the more narrower that beams. So for each SSB beam, for each beam location, we may have different SSB, and this is used to increase the probability of downlink synchronization for user equipment. Like in this example, for example, user equipment locates in that point of space, yeah? And the best correlation, the best received signal for user equipment is actually from SSB3, yes? Because it has the same direction, it directs to user equipment. So this is the main idea of beam sweeping, that it's used even for initial access procedure. So this was in time domain organization. In frequency domain, every synchronization signal block organized in a specific way, but the main thing is to have a coexistence with LTE system in order to avoid interference with LTE. So let's look inside SSB block, which signals and messages it contains. Okay, now let's look inside SSB block. SSB block contains the first signal is PSS. This is primary synchronization signal. It has 3 possible values, and it used for defining cell ID sector, cell direction of sector. Also, this signal is used for downlink symbol synchronization. The next signal is a secondary synchronization signal, and it may has 336 possible values for defining cell ID group. And this signal, again, is used for downlink synchronization on the frame level. And actually, after receiving and successfully decoding information from PSS and SSS, user equipment can calculate PCI. And PCI calculates in this way. This is 3 possible values of SSS plus value of PSS. And in 5G NR, PCI may range from 0 to 1007. As you can see, this is in 2 times more than it is in LTE. I think this is mainly because in 5G NR we go to use some new frequencies like millimeter waves, and the cell range and cell densification is going to be much more higher, and that's why PCI planning is going to be not an easy task. Yes, and in this case, in 5G NR, we use in 2 times more possible PCI values. So the next signal is a physical broadcast channel. It contains MIB, like in LTE, and like in LTE, it has 8 milliseconds periodicity. Like in LTE, it has a system frame number, cell bearing information, but also it has core set configuration, core set 0 configuration for monitoring PDCCH channel and for scheduling, for receiving information from PDCCH, and for scheduling PDSCH information, actually for scheduling SIB1 block and receiving some information about random access configuration resources on the base station side. So all of this information inside MIB is used for the next step. It is used for random access preamble transmitting. And again, many things like in LTE, but actually what's more we can say is SIB1 and PDSCH resources may have different subcarrier spacing, may have different numerology, and this information is also inside master information block. So the UE has to decode it and understand. And actually PSS and SSS modulated by BPSK modulation, and physical broadcast channel has QPSK modulation. PSS and SSS should be more robusted, should have a stronger signal layer and a stronger signal to noise ratio in order to perform downlink synchronization. So that's why these signals modulated by BPSK, and broadcast channel is modulated by QPSK, not only because BPCH channel is not the first channel, yes, in this process, but also because because physical broadcast channel contains lots of information, and this information should be carried by more modulation techniques like QPSK. So let's move on to demodulation reference signals. In 5G NR, we have to use special reference signals because there is no special cell reference signals like it is in LTE that transmitted every time. In 5G NR, we transmit cell reference signals only inside PBCH, only inside SSB block. This I suppose performed only in terms of energy saving and power saving techniques. So this demodulation reference signal is used like in LTE, the same for measurements, for defining and calculating RSRP, RSRQ, and the position of these demodulation reference signals may vary inside PBCH channel, may vary from time and frequency domain. And the variation depends on the value of PCI, so like in LTE. And actually using this signal, a user equipment can calculate RSRP, RSRQ and define the SSB block, the best SSB block, and in this case we can say that it is equal to defining the best beam for initial access procedures. So these reference signals is very important and perform many things in terms of beam sweeping. Okay, after decoding PSS and SSS, after defining PCI, user equipment is synchronized in downlink direction. And now user equipment has to synchronize in uplink direction by performing random access procedure. So let's look at this step. So now let's look at uplink synchronization procedures. As we already know, G0B sends different beams with different SSB blocks that organized in SSB burst sets towards user equipment, and the UE try to measure it and define the best beam by decoding SSB, by decoding demodulation reference signals and calculating RSRP, RSRQ levels. By decoding SSB, the UE know exactly how to transmit SIB1 block with random access channel configuration that is necessary to when the UE wants to send preamble towards G0B. So at this step you receive SIB1 block with resource allocation, and now user equipment form its own beam towards the same downlink beam that was used for receiving PDSH, for receiving SIB1. So we have kind of a pair in uplink and in downlink direction, and this is actually the fundamental difference. This is the major difference in 5G in terms of initial access procedures, because for that step user and base station use beamforming techniques. This is very important point. So UE sent message 1, random access preamble, towards G0B, trying to synchronize and establish connection. And up until this point, it was actually cell-wide beam. So a beam was much more wider. It was a kind of a common beam for many possible users, to cover as much as possible locations with potential users. And after this, when UE and G0B know exactly the direction by the best correlation of signals, we have more narrower, more stronger beams, and we may call these beams user equipment specific beam. And at this step, we the UE and the base station use CFRA signals, special reference signals for reporting beam measurements. So next messages is pretty common, as you may see. So we the UE receive random access response message 2, and connection request message 3, then connection setup and setup complete, and after that connection is established. So again, one more time, the fundamental difference is using beamforming in not only in downlink but also in uplink. And up until this point, we have only wide beam with wide coverage, and after synchronizing in, let's say, after defining the best beam, UE use user equipment specific beams. And this is again a very important point to know and understand. And now let's look with more details about what's the difference between standalone and non-standalone, because this situation is for standalone mode. This situation is for when the UE perform access to G0B without LTE lag. And in case of non-standalone, in case of dual connectivity with LTE, user equipment receive all necessary random access configuration and PCI value and other possible things to perform initial access. User equipment this received from LTE network, from LTE base station via RC reconfiguration message. And this is again a very important point to know and understand. So now let's look with more details about random access procedure. So there are two types of random access procedures. It is contention-based procedure and contention-free random access procedure. Contention-based is used for initial access in case of standalone option, in case of 5G NR. Contention-based is used for uplink synchronization if uplink is unsynchronized. And contention-based is used if contention-free random access is failed because it was the message was unacknowledged from base station. So contention-free used for beam failure recovery, for handover, and for requesting system information. Actually, requesting system information and beam failure recovery, this is a new feature in 5G NR. This is a new. And actually contention-free used for cases when user equipment in connected mode. So as you can see, the main differences is that in case of contention-based, there are contention resolution messages, and it resolutes in that way. In case of contention free, user equipment use special dedicated preamble that was dedicated from G0 B, and this is especially useful in case of handovers, and it may be actually handled in hardware. So when it comes to preamble sequences, there are two types: long sequences and short sequences. Short sequences is used for FR1 and FR2, but basically used for small cells, for indoors solutions, and short sequences has more broadened subcarrier spacing. Whereas long sequences, it's pretty similar to LT, and it used in other cases. There are one more interesting thing when it comes to random access procedure. It is in terms of using supplementary uplink. If network configured with supplementary uplink or decoupling, and if you want to know more about this, you can watch my video about decoupling, about supplementary uplink here. So in case of this, network can help to user equipment to define which carrier have to use for random access procedures, for random access messages. Supplementary or just a regular uplink carrier. Otherwise, user equipment would define the special threshold, would calculate the special threshold, and if the signal strength in downlink direction is lower than this defined threshold, user equipment would use supplementary uplink in order to gain the probability of random access procedures. So actually it was my lesson about initial access in 5G NR. I tried to cover every possible steps, and if you have any questions, you can send me any questions in my email or in comments below. So if you like this video, you can like and subscribe to my channel. Goodbye.